What we're going to do first is go over some examples of section 1 that we did the other day. And then we'll do section 2, and if we have time, section 3 today. Let me give you a heads up. This is going to be the most difficult chapter because what's going to happen here is, up until now, it's always been simple equations, linear equations, quadratic equations. Or if it's a cubic, we can use grouping method. But what if it's larger? What if it's like a degree 9 or degree 12? If it's a very long polynomial, can you find the x-intercepts there? That's what this chapter is all about. All right. So to begin with, let's look at example 1. Go ahead and match these 4 functions with these 4 graphs with what we know so far. With as fast as you're writing stuff down, I can tell that you don't remember what we did Tuesday. What do you look at to tell what the graph's going to look like? From class Monday, what do you look for to determine what the graph's going to look like? The degree. And where is the degree located? It's the first term, right? So it's the leading term. But that's not the degree. The degree is what part of that? Very good. The degree is the largest exponent of x in the equation. Because you may be given a polynomial where it's not in decreasing order. So the first thing you're supposed to do is put all the exponents in decreasing order. If you notice all these, it's exponent 4, exponent 3, 5, 1, 3, 2, 1, 0, 6, 3, or 6, 5, 3. So you rearrange them in that way. So the degrees are going to be the largest exponents. What else do you look for? And okay, what does the degree tell us? What does the degree tell us? You're right. Right. It tells us the end behavior. In other words, the direction the graph goes, both ends. Okay, so that tells us whether they both go the same direction or if they go opposite directions. What determines which one of these pairs it is? Because if your degree, and we'll call that n, if n is even, then they both point the same direction. If the degree is odd, they point different directions. So what determines which one of those sets it is and which one of those 2 it is? The leading coefficient. We call that A. It's the number of the first term. It's whatever's in front of x of the leading term. So if A is positive and n is even, it goes up. If A is negative, it goes down. If A is positive, it's an increasing function. If A is negative, it's a decreasing function. And I gave you the leading term test table. If a is greater than 0, if a is less than 0, if n is even, if n is odd. So you should have at least memorized that from Monday or Tuesday. Okay, so with what we know here, let's look at these. It's degree 4. A is positive. So what is it? What's the graph going to look like? They both go the same way, up or down. They both go up, up. So it has to be D. How about B? What does this one tell us? No, that's not what it tells us. What does the degree tell us? They go opposite directions, right? And then the right-hand side, since it's negative, goes down. So opposite directions, the right-hand side goes down, so it's B. And C. The degree is 5, opposite directions, and the coefficient is 1, positive 1, it's greater than 0, so it's A. Degree is 6. They both go the same direction. They both go down, so this one is C. Again, knowing what the graph's going to look like is our first step. Because our ultimate goal is I'm going to give you a large polynomial, and then you'll be able to graph it. You should know at least what it's going to look like before you go anywhere. Example number 2. Consider the polynomial x cubed plus x squared minus 17x plus 15. Notice the exponents, the degrees, 3, 2. If there's nothing there, it's a 1, 1, 0. It's decreasing order. Now, this was asking, determine whether the numbers 2 and -5 are zeros of this polynomial. Zeros are what x values, what do you put inside there to make the function equal 0? That's why it's called a 0. So let's try them. We put 2 in the first one. And work it out. If it equals 0, then x equals 2 is a 0. 2 cubed is 8. 2 times 2 times 2 plus 2 squared is 4. Negative times positive is negative. 17 times 2 is 34 plus 15. 8 plus 4 is 12. By commutativity, I can add these two, associativity. 12 plus 15 is 27. Since 34 is bigger, answer is negative. 34 minus 27 is negative 7. So 2 is not a 0 of P of X. And then we check the next one when X is -5. negative 5 cubed, negative 5 squared, minus 17, negative 5, plus 15. If you have a negative inside an exponent that's odd, it'll always stay negative. So the answer is going to be negative because that negative is inside the parentheses and it's odd. So 5 cubed is 5 times 5 is 25 times 5 is 125. The negative's inside, but it's an even power, so it means it's going to be a positive. So we'll leave that sign there. 5 squared is 25. Negative times negative is positive. 17 times 5 is 35. 5 is 85. Plus 15. What do we do? Negative 125 plus 25. Negatives 125 is bigger. 125 minus 25 is 100. 85 plus 15 is 100. That works. So x equals negative 5 is a 0 of the polynomial. So what does this tell us? What does this mean? If we find a 0, what does that tell us? What good is it? Actually, more than that, it can't be solved. We solved it, actually, because 0 is the same thing as a solution, is the same thing as an x-intercept. The 0 of this equation is x equals negative 5. The solution is negative 5. And the x-intercept is negative 5 comma 0. So that's what we're trying to, that's the whole purpose we're looking for here. Because what we're looking for is, I'm giving you a polynomial, you have to find the x-intercepts. Do we know the y-intercept of this equation? Do we know the y-intercept of this equation? Yep. It's always, in standard form, it's always a constant. So we have one of the x-intercepts, and we have the y-intercept. So we have 2 points. How many more points do we need from this equation? We have one solution. How many more are we supposed to get? Remember, the polynomial was the degree tells us how many solutions we're supposed to have. We're supposed to have 3 solutions. So we have one of them. There are 2 more as well. 2 more I have to find. And that's what we're going to do in section 3 of this chapter. All right, let's look at example 3. Find the zeros. Okay, in this case, we were lucky enough to have it factored out for us already. In this chapter, after the next section, we won't do that anymore. You'll have to find all those. That's what the whole purpose of this chapter is about. The zeros are found once we factor out the equation. We set each of the factors, the binomial factors, set them all equal to 0. So we'll have x minus 2 equals 0, which means x equals 2 is a solution. That's an x-intercept. We have x equals 2 again, and again. And then we have this one, x plus 1 equals 0. So x equals negative 1. That's another x-intercept we have. Okay, so we have the x-intercepts. It's going to be negative 2, or positive 2 and negative 1. What's our graph going to look like? What's the graph of our equation going to look like? Again, if you don't know, ask. Staring at the board is not going to help you much. Because even though, as I told you all, beginning of the semester, even if you make an A in this course and know nothing after this course, you're going to look like a really, really, really embarrassed person if the next course you take that requires math and you can't do basic math. Do not blame it on me. I give you all the options I can to take the stress off of you, but if you abuse it and cheat to get a passing grade, I'm sorry. Don't blame it on me. My job is only to give you the information. Your job is to learn it. By this stage, you guys all should be able to answer these questions for me. What do you need to graph an equation? You need the x-intercept. What else? The y-intercept. We need the x-intercept. We need the y-intercept. What else? The shape of the curve, the direction of the curve. All of that stuff we can see right here in this equation. The x-intercepts are given to us here. Those are the factors. What's the y-intercept of this equation? How do you mean? How do you find the y-intercept from chapter 1? How do we find the x-intercept? What do we do? To find the x-intercept, we set the equation equal to 0. This is the y. So to find the x-intercepts, we set y equal to 0 and solve for x. So extrapolate that. How do we find the y-intercept? Set x equals 0 and solve for y. So in our equation, we have this one here simplified. Notice we have x minus 2, x minus 2, x minus 2. There's 3 of them. That's why we have the exponent there. X plus 1 only happens once. That's only one of them. So if we set that equation, right, we're looking for the y-intercept. If we set all the x's to 0, and solve for y. 0 minus 2 is negative 2 to the power 3. 0 plus 1 is 1. Again, since we have a negative inside the parentheses and it's odd, the answer is going to be negative 2 to the third power. So it's 2 times 2 times 2. You don't have to raise your hand. This is not high school. Because we're looking for the intercepts. Is it from chapter 1? Well, Yeah. So at the x-intercept, y is 0. For the y-intercept, the x is 0. So 2 cubed is 8 times 1. Positive times negative is negative. 8 times 5 is 40. So our y-intercept is at negative 40. No, because it's inside the parenthesis and it's an odd exponent. So it's negative 2 times negative 2 times negative 2. It's negative 8. So this one becomes negative 8. 1 just disappears because anything times 1 is itself. Okay, so let's look what our graph looks like so far. Our x-intercepts are at negative 1 and at 2. And we have a y-intercept at negative 40. So what's the equation? What's the graph going to look like? What's the degree of the equation? You were going to say it first time before you changed your mind. The degree is the largest exponent, right? The largest exponent tells you how many solutions you're going to have. So we have how many solutions here? 1, 2, 3, 4. So our degree is 4. Another way you could do that is once you're in factored form, add the exponents of those factors. 1 plus 1 plus 1 plus 1 equals 4. Or on the bottom here, we have 3 plus 1 equals 4. So our degree is 4. What does that tell us about our graph? Degree is 4. They both go the same direction. Go up or down. Is there a positive or negative? It's positive because in this case, whenever it's factored form, look at all the coefficients of x and whatever's in front. They're all positive, so a is positive. It's actually positive 5. So since our degree is 4, or n, I should say, and a is positive, from our endpoints, from the farthest end dots, we know that they both go up. The graph goes up. This is what I call it the end behavior. Out of the last dots, what happens to the graph? Okay, now, remember, our polynomial was factored out into this. These exponents here are called the multiplicity. These exponents, pretty much all the multiplicity tells us right now, it tells us how many times the answer appears. So this one's, the first one says, our answer to this equation occurs 3 times. Our solution for the second one occurs once. And that's what it said originally. X minus 2, x minus 2, x minus 2, x plus 1. That's what the multiplicity tells us. But it also tells us something else. If the multiplicity is even, the graph bounces at that point. If the multiplicity is odd, the graph crosses the x-axis. Bless you. At that point. Allergic to math? Again, the multiplicities, if they're even at that solution, it bounces off the x-axis. If it's an odd multiplicity, then it crosses. So at the solution for this one, when x is 2, multiplicity is odd. So at 2, we know it crosses. We know it crosses the x-axis. And at -1, multiplicities are odd, so it also crosses. So we know that at the endpoints, the graphs cross. It has to cross through this -40. Our graph looks something like this. Because the degree is 4. If the degree is 2, then it's parabolic. If the degree is 4, it's like this. If the degree is 6, it's like this. It crosses the x-axis at most 4 times. This one twice. This one 6 times. So again, the degree tells us the shape of the curve, what it may look like. The degree also tells us something else now. Tells us the maximum number of vertices in our graph. In our graph. What is a vertex? What is a vertice? Vertices is plural of vertex. What's a vertex? We talked about this in chapter 2. The vertex is the lowest or highest point of your curve. It's either the lowest part of the curve or the highest part. So notice, when n equals 2, when our degree is equal to 2, how many vertices do we have? When it's 4, how many do we have? When it's 6, we have. So what is it? What do we know about the degree and number of vertices? Yeah. So the number of vertices is equal to n minus 1, where n is the degree. So we know our graph is supposed to have 1 less than the number of x-intercepts we have. These x-intercepts, our solutions, also have another name. They're called our critical values. Because at the critical values, at these x-intercepts, on one side, you can tell whether the graph's going to be above the x-axis or below the x-axis. Again, that's all determined by the multiplicity of your function, of those factors. All right, let's look at example 4. Find the zeros and sketch the graph. I want you to tell me all these things here. Tell me the x-intercepts. Tell me the y-intercept. Tell me the degree. And sketch the graph. What's our degree? 4. Because we're going to have 4 solutions, or just add the exponents, we'll get 4. So we know, what's our value for A? Very good. Because all of these x's are positive, so that's not going to change anything. So whatever's out in front is your leading term. So it's -1. So we know our A is negative and our degree is even. So what's our graph going to look like? Both ends going down. So it'll look something like this. Since it's a degree 4, we're going to have 3, at most 3 vertices. So our x-intercepts are where? Remember from when we did the circles, when we did the h and k from the circles, whenever you have something in parentheses, it's always the opposite of what's inside the parentheses. So the x-intercepts are at +1 and -2. Again, if you don't see that, then what you have to do is take each of these and set them equal to 0. That's just a shortcut. It's just opposite whatever's inside the parentheses. So our x-intercepts are at 1, -2. And our y-intercept is where? Not the equation, the x's. We're solving for the y-intercept. So we have -0 minus 1 squared, 0 plus 2 squared. You can use either one of these if you want. Doesn't matter. The negative. So we have 0 minus 1 is -1 squared. 0 plus 2 is 2 squared. -1 squared is +1. 2 squared is 4. 1 y-intercept. Because we found our x-intercepts here. Set y equal to 0. Basically, when we set y equal to 0, we're setting each of these separately to equal 0. So the y-intercept is at -4. And we know the end behavior is at both ends it goes down. So we have our x-intercepts at 1 and -2. We have the y-intercept at -4. And we know at both ends, the graph goes down. So at -2, does the graph bounce or cross the x-axis? At -2, it comes from here. The multiplicity is even. If it's even, what does it do? It bounces. If you don't see that, how do we graph the function x squared? We know that's the parabola, and it only touches at the origin. So if you have an even exponent, it only touches. And at 1, it's also even, so it bounces there too. So it looks something like this. One, two, no, it'll be like this then. Because we only have, remember, we only have 3 vertices. It looks something like this. All right, let's look at example 5. Find the zeros. Ruh-roh. It doesn't factor it for us. So let's talk about this part now. Factoring polynomials. The first type, we can have binomial polynomial. Binomial means what? 2 terms. So the first case, both terms have x's. Solve that. So if both terms have x's, your steps are factor out as many x's as the smallest exponent says. And also remember, since we're solving for the solutions, we set y equal to 0. I forgot to put that in there. Set y equal to 0. Now, how many x's do both of these have in common? They only have one. Because we can look at this, we can only look at the smallest exponent. They only have one x in common. And then whatever's left goes inside the parentheses. So if we took out an x out of the first one, we only have one x left. And we took out one x from the second one, so we just have the 4. Each equal to 0. So anything that has an x, set that equal to 0. And solve. So here's the first solution. It crosses at x equals 0. And the second one, subtract 4 from both sides and divide by 3. Subtract 4 from both sides. This is the part a lot of students forget. If you have an x out in front, you have to set that equal to 0. Anything that has an x touching it, set that equal to 0. That's if they both have x's. The second form, if only one term has an x. If only one term has an x, like well, since I have two terms here, I set that equal to 0, and I set that equal to 0. Since I set x equals 0, that's as far as I can go there. The x equals 0. Isolate the x. If you only have one x, well, if only one term has an x, isolate the x. Well, actually, again, I keep on forgetting. Set it equal to 0. So we add 16 to both sides to get the x by itself. And then solve for x. Divide both sides by 4. So x squared, 16 divided by 4 is 4. Square root both sides. What am I missing? I'm missing something in this last step. Whenever you square root something squared, always put a plus and minus in front of the answer. The square root and the square cancel. The square root of 4 is 2. So x can be positive or negative 2. Those are your two answers. X equals negative 2 and x equals positive 2. This is called the square root method. If you only have two terms. Plus or minus. When the exponent is even and you get rid of it, the answer always has a plus or minus. If it's odd, if we had x cubed equals negative 8, because that's a 3, I would have to take the third root of both sides because these numbers have to cancel. Now, what number multiplied yourself 3 times equals negative 8? Yeah, so if it's odd, if the degree is odd, then the answer is going to, if it's positive, it's positive, it's negative, it's negative. But if it's even, then if x squared equals 4, I could put negative 2 in there, and I could put positive 2 in there. That's why it's plus or minus 2. Okay, so that's if you have a binomial. If you have a trinomial, in other words, if it's this is called quadratic in form. Quadratic in form. What this means is this. What makes it quadratic in form? After everything's said and done, the last term is a constant. The middle variable, its exponent, in this case, it's 1. If I multiply it by 2, does it equal the first exponent? In this case, because this one's x to the power 1. If I multiply by 2, I get x squared. Yes. So that's quadratic in form. Is that quadratic in form? Yeah. Because if I take this exponent and multiply it by 2, does it equal that? Yes. Last term is a constant? Yes. That's what we did in chapter 2. We learned how to solve for complete the square. We learned how to solve factoring. We learned how to solve using the quadratic formula. Notice the middle term is the important term here. It tells us if it's really quadratic or not. The quadratic formula was that? Remember that formula? That's if it's like this. Because if you notice, what is the equation solving for? It's solving for the middle variable. This formula solves for the middle variable. That's what the x is talking about. It's that. So if I had this type of equation, I would be solving for x squared and the same formula. Yes. Formulas? Memorization. See, if you memorize something, you'll forget it. But if you learn the process, that's why I apologize. Last week, I didn't show you guys how to derive it. Complete the square is pretty much straightforward. Move it over, add b over 2 squared, and then simplify. We can derive it, but at this stage, it's the more you write it down, the better it is memorizing it. So whenever you have an equation, write down the formula before you start calculating. I guarantee you, if I look at your notes or your homework assignments or your scratch papers, if you have a quadratic equation, you just jump straight and put numbers in there. You have the formula here, you start up. No, whenever you have a quadratic equation, always write down the formula, the quadratic formula, before you start doing anything. The more you write it down, the better you'll memorize it. But no, in my class, no, is you have a formula sheet. But in any other classes, yes, they expect you to memorize this for whatever courses you get into. So if you have a trinomial, then you can either factor, complete the square, or the quadratic formula. And that's what we did the last chapter. So that's why I'm not going to worry too much about trinomials. The last one we're going to talk about that has a process. If you have a quadrinomial or a cubic equation. In other words, if you have 4 terms, if you have 4 terms, use grouping if possible. So if you have a quadrinomial, we have 2 possibilities of what could occur here. Because when using grouping, we put parentheses around these things. So we put a parenthesis around the first 2 and a parenthesis around the second 2. Now, here's the difference between the 2 methods, the 2 types of equations. If you have a plus in the middle, then you can put parentheses just around the numbers on both sides. Leave the plus by itself. If you have a minus in the middle, include that in the second parenthesis. Include the minus in the second parenthesis, because we'll have to factor out a negative number there. Let's look at example 5. All right, and here's example 5. Find the zeros. We have x cubed minus 2x squared minus 9x plus 18. We have 4 terms. It's a cubic equation because there's a 3 there. That's what makes it cubic. So we put parentheses around the first 2 terms and include the negative in the second 2 terms. Okay, once you do that, now factor both of these separately. What do they have in common? Put it out in front. So what do these two have in common? They both have, remember, it's always the smallest exponent you can take out. If I took out 2 x's out of the first term, I just got 1 x left. And I took out 2 x's from the second, I just have a 2 left. Do the same thing with the second one. But because that's a minus sign there, you have to take out the negative sign also. So what do they have in common? 9x and 18 have, well, they both have a 9 in common. So we factor out a negative 9. So to see what goes inside the second parenthesis, we divide both of these by what we factored out, negative 9. Negative and negative becomes a positive. The 9's cancel, so we have an x. Positive and negative makes it a negative. 18 divided by 9 is 2. This is what we're looking for. We're looking, both of these have the same thing in common, right? We have this term out in front and the second term here. What do they both have in common? Right. In the second parenthesis, put the coefficients of those parentheses. So x squared minus 9. How many answers are we supposed to have here? What's the degree of our equation? No, the degree is 3. We're going to have 3 answers. I'll show you. So now what we do, we set y equal to 0. And set both of those individually to 0 and solve. So the first one is going to be 2. There's our first solution. In the second one, add 9 to both sides. X squared equals 9. I have to get rid of the square, so I square root it. So those cancel. So I have X. Since I square rooted a square term, I put a plus or minus in front of the answer. Square root of 9 is 3. Those are my three answers. X equals 2, X equals -3, and X equals 3. Those are my x-intercepts. Yes, it doesn't matter how many parentheses we have. It's the leading exponent. Because inside here, there's two of them. Inside here is one. And we know our y-intercept is going to be 18 because -2 times -9 is positive 18. Or we could look it up here. So we have our intercepts. At +2, +3, and -3, and at +18. It's a cubic equation. What's the end behavior going to look like? What's the graph going to look like? Remember, we look at the original equation. It's what? Well, both ends, they point the same or at different directions. They point different directions, and the right side, since it's positive, points up. It's an increasing function. So they point different directions. So this side points down, this side points up. Since we have three answers and we have supposed to have, that means they each have multiplicity of 1. Because this has 1. This one is actually x plus 3, x minus 3, which is their multiplicities are all 1. So that means we cross at each of these. It grows up here. That means this one has to go down. That means this one has to go up. That's what our graph is going to look like. Again, all we need right now is just the basic shape of the curve. To get better points, we'd actually plug in some numbers and see what it takes us. And the last one for this section, find the zeros. What can you tell me about this function? It's quadratic in form, right? Because the middle term times 2 equals that. So it's quadratic. What about the end behavior? They're both going up. They're both the same direction. They're both going up. They're both going the same direction because that's even, and it's positive, so it both goes up. So we know the graph will look something like this. We'll have at most 4 solutions. Set that equal to 0. Fortunately, this one, if we can factor, is much faster. The quadratic formula would also work here. So what goes here is actually that, x squared. So what times what gives you x to the 4? X squared, x squared. The second sign's a minus, which tells us what? One's positive, one's negative. And so which sign does a bigger number get? The bigger, once we find the solutions, the bigger number gets a positive sign. So next thing, 1 times 45. What times what equals 45? When you subtract them, they equal 4. 9 and 5. 9 and 5. So 9 goes there, 5 goes there. Again, as we did in chapter 2, this is the hardest part, to figure out what two numbers multiply to give you the 45. When you add them, you get the 4. That's the hardest part. Now we take both of these equations and set them equal to 0. Subtract 9, so I have x squared equals negative 9. Add 5, x squared equals 5. I have to get rid of the square. How? Square root both sides. So the x squared and square and the square root cancel. So we have x equals plus or minus. Square root of negative 9 is what? Nope. Negative 3 times negative 3 is positive 9. Remember when we talked about complex numbers? Because there's a negative there, there's an I. So the square root of 9 is 3. So there's plus or minus 3i. And x equals plus or minus square root of 5. So what is this graph going to look like? We only have two real solutions. We know a is 1. It's greater than 0. We know the degree is 4. So both ends have to go the same direction. Square root of 5 is just a little bit bigger than 2. Because square root of 4 is 2. Square root of 9 is 3. So this one is positive, let's say there, and negative, this one there. And we know that they both ends have to go up. And we also know that our y-intercept is negative 45. So we have to cross at negative 45. The multiplicities of these factors are both 1, so we cross. So this graph will look something like that. Because remember, it's supposed to have 3 vertices, but we only have 2 x-intercepts. So that means that the next bend will happen off the x-axis. I mean, it could be up here, it could be down here, it could be anywhere. We have to find points. And that's what we're going to do. We'll figure out better graph of this one in the very near future. But that's it for today. Next week, we're going to do graphing, and then we're going to start learning about how to break apart larger polynomials to find solutions for them. Because at the end of next week or the week after, you're going to be able to solve equations like that. I give you any size polynomial. You'll be able to figure out the x-intercepts, the y-intercepts, the shape, the direction, everything. And we'll even find points on the graph. But that's in a couple of weeks. This is the hardest part of this chapter, is the hardest part of this course. Once we get over this, it's